Hey folks, Sega Sonic fan here, and today I'm looking at the VA0. I believe this is the original iteration of the Sega 32X, also known as Super 32X, also known as the Sega Mars project. And this is a really interesting piece of hardware, actually. I'm actually not a big fan of the software that was made for this thing. A lot of just shovelware garbage. But the hardware itself is absolutely fascinating and is a really interesting stopgap between Genesis and Saturn. And I think if it had better support in software and just, from Sega in general, when Sega of America and Sega of Japan were fighting, uh, it really would have done well. So it's a great piece of tech. And it's really kind of the first thing that Sega produced that could do sprite scaling just in a really, really solid way. But I'm here, of course, to talk about mostly hardware and the chipset that's inside this thing. So the power supply issue is the main issue I want to talk about here, and the noise that it creates in the video output, which is a common annoyance. And there's a great thread on the Shmups forum, which I will try to link in the description here, explaining some of the issue that people have, and I have. It's a common issue, I guess, but not extremely well documented in the sense that people don't know exactly what causes it. And I think I have a little bit of answers as far as that goes. There's some great documentation that's been dumped thanks to OMP from the Sega 16 forums doing the PDF scans. I believe it was him that did it when people bought the service manuals as a community back in 2013, which was awesome. And so, yeah, let's do a little rundown of what's going on here. So you got your power input. There's some EMI filtering in here, and then the circuit is fed through a classic MC34063 DC to DC converter, and then this is a PNP with a catch diode, and then there's an inductor here. That's just the whole DC to DC converter arrangement in that part of the board. You have your 5-volt output comes from this large capacitor. This has actually been replaced. There's a specialized, it's a purple capacitor in here, CON, I forget the name of it, but it's basically a very low ESR capacitor that they used. I'm not entirely sure why. I think that was to help the noise and also possibly save costs on having to get a larger value capacitor with a larger footprint. But pretty fascinating stuff. I actually put in an aluminum polymer in here to try to compensate for that capacitor. And then there's this inductor here, and this actually comes from the 5-volt rail and to another 5-volt rail. So this is basically your analog video 5 volts comes from that. The inductor uses an LC low-pass filter to help out with some of the noise. And it's a similar noise filter that they used in the Game Gear as well. This audio amp right here is the 31556, God, what is it? Let's look at it. Yeah, 5684. And that's used in all their Genesis type hardware from this era. It's considered pretty decent. And it's basically a bunch of op amps in one package, in one custom package. And it's it's used inside all the Genesis Model 2 stuff. I believe it's in the Sega Nomad. It's definitely in the 30s in the CDX, and I think all the VA3 and VA4 Model 2 Sega Genesis systems. So they obviously were a fan of that chip for their audio, and of course it's not as good as the Mega Amp and Crystal Clear audio upgrades that were created by TmEE and Ace and Villahead. I do think TmEE deserves most of the credit for coming up with that circuit, by the way. I don't think he gets enough credit, but that's what's going on there. And then down in the cartridge slot, I'm not going to take this out right now, but there's your main chipsets, which are the SH2 microcontrollers and a couple other things going on in there. That's kind of the bulk of what the 32X actually is, the heavyweight stuff going on in there. But that's a whole digital area, so I'm not really that concerned with it. What I'm concerned is with the analog problems, which are on this outer board. Over here is your video converter, and in its follow-up video I'll make to this, I'll go over the schematics in more detail, because this video converter is actually fascinating. This is a chroma encoder, and it's also, I believe it manages the two RGB inputs, or the RGB from the Genesis and the RGB from the Mars chipset. This encoder is really awesome. Really, really cool stuff. They fixed a lot of their issues with the Genesis video output by developing a better encoder, and I'll go over that in more detail in the follow-up video because it's really cool stuff. And yeah, I think I actually haven't really looked at the chip that's down in here, but perhaps I could do that now. Yeah, I don't know what that is. Oh, 74LS. Oh, it's just an inverter. It's just a 6-pack inverter, and these are probably used to create the master crystal oscillator. Of course, I can look at the schematics later and find out for sure. So that's kind of a quick rundown of the analog part of the circuit board. This particular system was rusted real bad, and it required a lot of cleanup work, which I never would have done back in the day because these were basically being thrown out left and right. I remember back in the day, you could get these for $5, $10. I think you'd get a really nice one with shipping for $20, $30 if you really didn't care at all about looking. And now they're like $100 or something, which is totally crazy to me because there's not a good library of games for this thing. I really, really have some strong criticisms of the library for this. But I do like the Afterburner and Space Harrier ports. I think those are amazing. Those are extremely well done. But aside from that, I can't say much. I have a friend who loves virtual racing on this thing. But I do think the hardware is fantastic. They could have ported so much of their sprite scaling arcade hardware from that era, that 68K based. It would have been fantastic, but that didn't happen. So maybe someday we'll get some fan-made games for this, get some more fan-made games. But yeah, let's talk about the problem with, or maybe I'll save that for the follow-up video. I'll talk about in more detail the problems that go on here. Essentially, they really miscalculated when they designed that that circuit, and I believe part of it is they should be using switching FETs, which is how pretty much all DC converters do, instead of this PNP. And there's a saturation state that the data sheet documents that they possibly did not take into account in the engineering team that made this. I think it's really interesting that it even has a DC to DC converter. All the other Genesis iterations use a 7805. A 7805 is just a step-down voltage regulator. It'll take your 7 to 10 or whatever volts that comes in here, and it'll just burn it off down to 5 volts. It'll just waste off, whatever it isn't using, and usually make a really clean output in the process. And that's just really standard for that era of electronics as well. So you might wonder, why is this the only Genesis iteration, including the Sega CD, that has a DC to DC converter? There's an exception with the CDX because it's so compact. But why the 32X? And the answer is simple. The answer is power. Sega clearly wanted to use the original power supply that the Genesis used so that you could swap them. You wouldn't have to necessarily have a custom, 32X power supply. And so to do the more advanced chipset, which is doing a hell of a lot more than a Genesis does, it needs more power, and it can't afford to burn off the excess voltage coming from that main power supply. So that's my strong opinion of why they went this route. I think it's a really cool thing that they did that. They did not have to do that. Nintendo did a similar thing where they used their Super Nintendo power supplies that could power a Virtual Boy. Virtual Boy being the strong competitor of this system at the time in 94, 95. And I think it's really interesting that they actually went to these extra lengths to keep the compatibility with a power supply for something that was already in production. You would never see that nowadays, unless it was USB, of course. But if this is not even close to an interface. This is just raw power. And if you think about that, compare that to Apple products, for example, today that have their own connectors for absolutely everything. And every company out there is trying to milk customers for every dime on accessories and power supplies. And I really got to give props to Sega for actually engineering this thing in a way where you could just use your old Genesis Model 2 power supply that you had laying around, or, maybe find one at a thrift store or whatever, or just mix up your power supplies. I think it's really cool. And of course, they kept the mini DIN 8 jacks as well. It's just some really cool design ideas here. By the way, this thick red cable is power. They had to route power here. And then you have these large ribbon cables, because this is for all the data connections between the two boards, and these iron cores for EMI, reducing EMI interference, I'm quite sure. I will say that the heat shielding on the cart here is actually quite necessary, because those SH2 processors are under there, and that board gets pretty toasty. So don't remove that for any reason. But as far as the shielding on top, I wouldn't say that it's very necessary. In fact, I've been told the Japanese version doesn't even have that. What else can I say about this thing? It's got your classic, heavy duty grounding all around the edge, which I really like. I think it's done really well. My one big complaint about the hardware engineering, and I don't have as many as you would think, but my one big complaint is that these are labeled in black plastic. That always confused me as a kid, trying to figure out which plug was which, because they're identical, and that stuff was a lot more confusing when I was younger. But I think this absolutely should have been white. There should have been a white decal at the very least, to label those much better for input and output. They could have combined it into one plug that splits off as well. There's some things they could have done to simplify that part of it. But I think overall the main brains of this thing is actually designed quite well, especially when you consider how rushed the design was. And you can tell by the patched wires, and especially this resistor right there, just how rushed they were, sending these off to the factory. And I'm sure they produced a bunch of these boards, as an initial model. And then, engineer talks to his boss and says, hey guys, we need some connections in here, and we need this resistor here, and got to put some glue over here. And, we really would like to do another run of these boards. And of course, the engineer was immediately told, no, this needs to be out for the holiday season, because we need something to fill in, while the Saturn's in development and PlayStation's coming out, and time is of the essence. Console wars are at their peak. So I think it's a cool piece of history in that sense, where, they're patching these things and, sending them off to a fix-it factory, essentially, because they don't even have time to produce another board that incorporates those changes. I don't know if they ever made a VA1, but I do know in later models, which I guess would be considered a VA1, I suppose, that they replaced this chip with one that seems more reliable, I would assume. And this inductor ended up having more shielding, which is essential for EMI and vibration that it has. And I think also the frequency, I haven't actually done the math to calculate all of it, but I think they actually chose a switching frequency that's way the hell too low, because it's in the audible range and it makes a whining sound. And that's really bad. That means you chose the wrong switching frequency. And I'm not sure why they would have done that. But there are some definite mistakes in the power circuitry and in the labeling system here. But aside from that, it is a really solid piece of tech. It has it where it counts, I would say. And I'll dive into this more. I'm going to create replacement circuitry for this. And so in a follow-up video, I will show you the schematics for this, as well as the schematics for the video encoder, because I think they're fascinating. You can learn a lot from them. Hopefully this video is interesting to you. And if you want to see more stuff like this, leave a comment, say something nice. I just do these for free, so it's nice to get positive vibes from people. And that's it for this video. This is Sega Sonic Fan, signing out.